Example 3 says to convert 44 square inches to square centimeters. And I still have a few of you that they're really fighting me on the technique I'm trying to have you use on this. The technique I'm showing you is the most efficient technique, and when we get to ones that take 10 unit multipliers to fix, and you have to multiply sometimes and divide sometimes, if you haven't created this structure on your work of how to do these problems, you're going to be in big trouble. And as far as how to do these problems. So I'm going to ask one more time politely here. Please do it the way I'm showing you how to do it. I promise you it is very effective, and it will work every single time for the remainder of high school to do this. Whether you're in a science class converting units, whether you're in my class converting units, they are going to get much more difficult than what they are now. And if you don't go through some process to do them, they're very, very difficult to get the right answer to. So whatever we're trying to convert should go over 1. And it's 44 square inches. And what I usually do when there's a square or a cubic is I just put down multiple units like that.
That's what my squat pros do too.
Yeah. So instead of writing inches squared, I'm going to write inches, inches. And if we had cubic units, it'd be inches, inches, inches instead of inches cubed. I just think that that's a little bit easier to look at. We need to use facts that we know in order to convert from something to something. So if I want to go from inches to centimeters, there's a fact about inches and centimeters that says 1 inch equals 2.54 centimeters. That's the fact. That's not about inches squared, it's about inches. That's why we want to get inches, inches instead of inches squared, because we have facts about inches. We have no facts about inches squared.
That's why you put it twice.
Yeah, and so if I put one of these in here, currently I've got inches in the numerator. I need inches in the denominator for cancellation purposes. I need that to happen. And I'm trying to convert 2 centimeters, so I'm going to put centimeters in the numerator. 1 goes with inch, and 2.54 goes with centimeters. So I create this unit multiplier like this every single time. All that did was it took 1 unit of inch out of the problem and left the other unit of inch still in the problem. So I have to do a second, exactly the same. I don't have to put as much thought into this one. I just need to write it down a second time. This unit of inch cancels that unit of inch. And notice that I'm left with centimeters, centimeters, which is centimeters squared. That's what I'm looking for. And what we're looking at here is 3 things. Everything's in the numerator, so to get the answer, I simply multiply this times this times this. The numbers get extremely small and extremely large, so please use a calculator for these problems. 44 times 2.54 times 2.54 equals 283.8704. I'm fine with a couple decimal places. Let me say a couple non-zero decimal places. Like if it's 0.0000000078, don't just give me 0.00. Go to the first non-zero digit, go a couple digits there. Yes, Parker.
8704.
Again, 8704 is what I got also, and I said it was okay to round to a couple decimal places that aren't zero. All right, so the fact that 87, neither one of those is zero. If it was 283.00044, then give me 283.00044. All right?
That's confusing.
Is it?
All the numbers.
Just once the decimal point's there, once you hit your first not zero number, go one more after it. All right?
They say all the numbers go in my head and then they go right out. So I don't know.